Year 5 and Year 6, happy Thursday. It's almost the weekend, you've almost made it. Well done you. Thank you for joining me today for some arithmetic. Now, hopefully you've already had a go at the arithmetic questions, either in your maths book at home or on the worksheet on Class Dojo. And you're here because you're ready to mark your answers, or you might need a little bit of help and support with one that you've got wrong. Okay, now I'm going to start with the lower key stage questions, and then I'm going to go on to the Year 5 and 6 questions. Now we're all different learners and we will have all accessed something different today. So if you need to fast forward the video to the Year 5 and 6 questions, that's absolutely fine, okay? I trust you as learners to make a good decision about what's going to challenge you and what's going to stretch you. Okay, let's get started then. So, lower key stage questions. Question 1 was 34 times 2. Now we know that when you're timesing by 2, that's the same as doubling. 2 lots of something. So again, I've got my deans here ready to help me. And I've got my 30 4. Okay, so I've got 3 lots of 10s and 4 lots of 1s. Now to double this number, I'm going to need 2 lots of it. Here you are, here's my second lot. So I've got 2 lots of 30 and 2 lots of 4. Now all together, I've got 6 10s or 60 and 8 1s. So the answer for number 1 is 68. Okay, I'm going to move those just out of the way so we can see my table for the next question. Okay, so question number 2. We've got 934 add 10. Sorry, add 100. Can't read today, Years 5 and 6. We're adding 100. Now, lots of you will know that means that we are focusing on the digit in the hundreds column. Now, I've got a place value chart here so that we can correctly identify which digit is in the hundreds column. And you're absolutely right, it is the 9. Now, if I've got 900 and I add 1 more 100, what do I get? That's it, I get 1,000. I've got no hundreds. I didn't add anything to my 10s or my 1s. They don't change, they remain the same. So the answer for number 2 is 1,034. Okay, let's have a look then at question number 3. 4 times 8. Now again, if you struggle with your times tables, we've got some methods, haven't we? And grown-ups at home might not be familiar with this, but we call this an array. Now, what we've got here is 4 lots of 8. So I've used sort of counters here, but you could use buttons or marbles or anything that you've got at home really that you can line up. So I've got 1, 2, 3, 4, 5, 6, 7, 8, and this is 1 lot of 8. I've got a second lot of 8 here, a third lot of 8, and a fourth lot of 8. So I've got 4 lots of 8. And then I could count those and find out what I've got all together. So 4 lots of 8 is That's right, 32. Now, some of you might have noticed that we could also think about, well, what happens if I know what 2 lots of 8 are? Some of you might already feel confident in knowing that 2 lots of 8 is 16. And if I double 16, I will get 32. Okay, so question 3, the answer is 32. Right, we're going to move on to question 4 now, which is 289 subtract 6. And what I've drawn over here is a number line to help us. So I know that I'm going to do 289 subtract or take away 6. So my answer's got to be smaller. When we are subtracting our answer, it makes our answer smaller. Now I know that I can partition 6 into 2 lots of 3. So I can work backwards now. If I take away 3, I get to 286. So I know 9 take away 3 is 6. Okay, I've taken away 1 lot of 3. Now I can subtract my second lot of 3. Again, I'm looking at this ones column. 286 take away 3 is 283. So the answer is 283. Right, let's have a look at the final question then. We've got 4.7 subtract 0.2. And you can see we've got a decimal number here. So I'm going to put it on my place value chart to help me understand what that means. Okay, so in the ones column, we've got 4 ones. And in the tenths column, we've got 7 tenths. And we want to take away 0 or 0.2. Now I'm looking at this and thinking that I can do that mentally, because in the ones column, I've got nothing to subtract. 4 subtract 0 is going to be 4. My decimal point stays in the same place, it never moves. And I can do 7 tenths subtract 2 tenths. 7 take away 2 is 5. So my answer is 4.5. Okay, well done Year 5 and 6 for staying with me. We're going to have a look now at our flashback questions. So flashback means revision. So these are things that we should be quite familiar with by now. And we should be able to work through these with our methods, feeling fairly confident. Let's have a look at question 1 then. Divide 930 by 10. Now, if you're not sure how to do this, don't forget that when we're in school, we use a place value chart to help us. Now, when we divide, our answer will always be smaller than the number we're starting with. Okay, now I'm dividing by 10. I've got to make my number smaller, so it's going to move to the right on our place value chart. And I'm making it 10 times smaller, meaning I've got to move every digit to the right by 1 place. And you'll remember that the decimal point becomes between the ones and tenths. It never moves. So my answer then, Year 5 and 6, is 93.0. Do you need to keep the point 0? Hopefully you've just said no, and you'd be right. The point 0 doesn't mean anything on that number. It's just showing us we've got 0 tenths. And actually, if we remove it, the number stays the same. We've still got 0 tenths. Okay, let's have a look at number 2 then. We looked at the perimeter on Tuesday together. So hopefully you've seen perimeter. And perimeter, you're looking at the distance around the outside of a shape. And in this case, we're looking at a rectangle. Now you know that the total perimeter of the rectangle, so all the way around the outside, is 24 centimetres. And actually, what I'm going to do, year 5 and 6, I'm going to write that on the outside so that we don't get confused and start thinking that we're talking about area. We're talking about perimeter today. Now, it's told us that this length here, this side, is 4 centimetres. So you'll know that this side is also 4 centimetres, which means we've got a total of 8 centimetres so far. Now, if I do 24 take away 8, what would I be left with? Well done to everybody who's just sort of thought 16 in their head. Now, I've got 2 lengths left. So I've got to share that 16 equally between the 2 lengths. If I'm sharing something into 2, that's the same as dividing by 2. So 16 divided by 2 is 8. Well done, everybody. So this length here is 8 centimetres, and this parallel side is 8 centimetres. Now I can do a quick double check. 2 lots of 8 is 16. Add 4 is 20. Add another 4 is 24. So if you've got the answer 8 centimetres, you can give that a little tick on your sheet. Let's have a look at number 3 then. Now we've done lots of work on these types of questions, so fingers crossed you're all feeling confident today. Now it says write an addition to check the answer to this question. 720 subtract 189 equals 530. Now you'll know, year 5 and 6, that we need to do the inverse. And when we're doing the inverse, it means that we're working backwards. So we're going to start with 531. I've popped that over here for you. We've got to add 189. And when we add those together, we're going to get 720. Let's do a double check. 1 add 9 is 10. 3 add 8 is, add 1 is 12. 5 add 1 is 6. Add 1 is 7. 720. Okay, so we know that we've got our addition right there, don't we? We've written addition, we know that that is correct. Okay, how many thousands are there in 4,520? Now, if you're not sure, you can put this number onto a place value chart. And year 5 and 6, you're really used to drawing these in your maths book. I know I've got one here that I've sort of made earlier, but you will know that we draw them like this at school, and we're really familiar with drawing those on our whiteboards and in our maths books. Okay, so just because I've got one here that I've made earlier, you are allowed to draw these for yourself at home. Okay, so how many thousands are there in this number? That's right, we've got 4 lots of thousands. So if you've got the answer 4 for this question, you can give it a neat little tick. Now, I'm going to go on to the year 5 and 6 questions now. And if you haven't done these, you can pause the video there, or you might want to have a look at them with me today to give yourself a challenge. Okay, so the first one is 6 times 5 times 4. And you'll know year 5 and year 6 that we start with 6 times 5. And we put brackets around it to show that that's where we're starting. We're probably feeling most confident with our 5 times table. So 6 times 5 is 30. We're going to jot that down so we don't forget. 30 times 4. Now we know that we can ignore the 0 to begin with. We can make it 10 times smaller, and we can do 3 times 4, which is 12. I ignored the 0 over here. I made it 10 times smaller, so I've got to put that 0 back on over here that I ignored and make my answer 10 times bigger, 1,200. Okay, question number 2 then. Hopefully, you've probably used the column method for this one. I've set this up here ready for you. You've remembered that the largest number goes on the top, and hopefully you've lined your digits up accurately. So you've got all the ones in line with each other, tens and hundreds. Okay, let's get started then. 5 subtract 6. Well, if I was to do that, I would get negative numbers, which isn't going to help me with this. So I'm going to exchange my 20, so it becomes 10. I'm going to pop that 10 next to this to make 15. 15 subtract 6 is 9. Again, now I've got 1 subtract 8. I'd get a negative number there, which isn't going to help me. So I'm going to exchange another 10. So 11 take away 8 is 3. Now I've got 8 subtract 5, which is 3. 8 subtract 0 is 8. And 3 subtract 0 is 3. So if you've got 38,339, give it a neat little tick. Okay, we're going to look now at question 3. We've got 70 multiplied or times by 110. Now I can see that I could begin by ignoring these zeros or making the numbers 10 times smaller. So then I've got 7 times 11, and I know I can do that. I know my 11 times table, that's 77. Now this 0 that I ignored over here, I've got to put back on to make my number 10 times bigger. And I've got to add this 0 on that I ignored, now to make it 100 times bigger. So 7,700. Give that one a neat little tick if you've got that one. Oh, we like these. Have a look at question number 4, everybody. So question 4. We know that 2 cubed means 2 times 2. Oh, what's going on with my pen? Let's change colour there. Doesn't seem to like that colour, does it? What should we go for now? Let's go for purple. Sorry, everybody. So 2 cubed means 2 times 2 times 2. So just like we did earlier up here when we had 3 numbers to multiply, we're going to start with 2 times 2, which is 4. 4 times 2 is 8. So this part of our question totals 8. Over here we've got 4 squared, and that means 4 times 4. And 4 times 4 is 16. Okay, so now we can do 8 add 16, which is, well done everybody, 24. You can give that one a neat little tick if you've got it. Okay, the final question then, number 5, was 4/7 of 49. Now I just want you to think about this part of the question first of all. 4/7. We know the denominator, or the number on the bottom, represents the whole. So I've got a whole chocolate bar over here for us. And we know this whole has been split into 7 parts. 1, 2, 3, 4, 5, 6, 7. So if I was to find out 1 part, or 1 out of 7, I'd have to divide the whole thing by 7, because I would be sharing it into 7 parts. So to begin with, I'm going to find 1/7 of 49. And to do that, I divide by 7. Now I can use my 7 times table to help. We can go 7, 14, 21. What comes next? 28. 35. 42. 49. So 49 divided by 7 is 1, 2, 3, 4, 5, 6, 7. So I know that this 1 part here is the same as 7. But I want to know what 4 parts are. Now if each of these are worth 7, how many will 4 parts be worth? 1, 2, 3, 4. So I'm looking at this section here now. So I know 7, 14, 21, 28. So hopefully you got 28. If you didn't, I hope that that short explanation helped. Right, let's have a look at your flashback questions then. And we're going to whiz through these quite quickly because I'm aware that I've been talking for a little while now. Right, we've got 220 times 20 equals 440. Now hopefully you've noticed that 440 divided by 2, or halved, is 220. Okay. Now in the middle here, you've got the equal sign. That means that both sides have to equal the same. So this side has to equal the same as this side. Now, if you've divided here, then you've also got to divide here by the same amount. So 20 divided by 2 is 10. Okay, hopefully that's helped year 6. Let's have a look now. We've got to calculate, so that means solve, or sort of work out the answer. Minus 12, or negative 12, add 13. Now add tells me the answer has to be bigger. Now when we're looking at negative numbers, the closer a number is to 0, the bigger it is. So if I've got minus 12 on a number line, I know I've got to move this way. I'm going to use a different colour just so we don't get muddled with the first question. I know I've got to move towards 0, in the direction of 0, because I'm making it bigger. And I've got to move 13 places. Now I know if I move 12 places on my number line, if I add 12, that will take me to 0. I want to get to 13, so I've got to add one more on. So that takes me to 1. So the answer is 1. Okay, let's have a look then at question 3. It says, put the numbers in ascending order. Now, I wonder who has remembered that ascending means smallest to biggest. Okay, let's have a look at the numbers then. We've got 9,979, 9,799, 9,997, 9,797. Now, some people like to put the numbers in a place value chart so that they can compare each number to see which is the biggest and smallest. Now, you don't have to do that. If you're feeling quite confident that you can look at these and spot the smallest number, then of course that is absolutely fine. This is just a tip to help those who need it. So the smallest number then is, that's right, 9,797. So I can cross that one out. And then the next smallest number is this one with 7 in the hundreds column, 9,799. My next numbers, they've both got 9 in the thousands, both got 9 in the hundreds. Oh, look, this one's got less tens. So this is the next smallest. And then that leaves us with the biggest number, 9,997. So hopefully you've got them in the correct order. Okay, last question for today then, year 6. And it's straight away, it's a word problem. So I'm thinking, right, we've got U, D, C. Underline, draw, calculate. So as I read, I'm going to underline the important information. A jug has a capacity, that just means it holds 2 litres. A carton contains 400 millilitres of juice. How many cartons will fill the jug? Okay, so I've got some pictures here to help me. I've got a 2 litre jug and I've got a carton of orange juice, which we know holds 400 millilitres. So I want to know how much orange juice or how many cartons can I pour in here to fill it up. So my total is 2 litres. And if we've got a bar model, the children will be familiar with these in school, but this might be new to grown-ups at home. Don't worry, the children have done lots of work on these. And 2 litres is the same as 2,000 millilitres. That's our total. The total always goes at the top. Now we know that we can definitely get one lot of 400 millilitres in. But how many can we get in total? Now if I was going to share 2,000 millilitres into 400s, how many would I get? Well, I could count up in 400s. 400, 800, 1,200, Oh, hang on, have I done that right, year 6? 4, 8, yep, I have, yep, sorry everybody. Up to 1,600 to 2 litres. So how many does it hold? 1, 2, 3, 4, 5. So I know that 5 lots of 400, 1, 2, 3, 4, 5. 5 lots of 400 make 2,000 millilitres. So it holds 5 cartons. Okay, hopefully then everybody, you're feeling quite confident with how we've got on today. I'm going to stop talking because this video is very, very long now. Have a lovely day, everybody. And if you've got any questions, please send me a message on Class Dojo and don't forget to upload your work.